calculate the energy changes in a system, we use the specific heat capacity required practical equation. So energy equals mass times specific heat capacity times temperature change. And that's the key bit. People often forget to calculate the change in temperature. So we've got 100 kilojoules. That kilo means times by 1,000. So we've got 100,000 joules of energy. Our mass is 3 kilos. Our specific heat capacity we do not know. The symbol for that is C, so I'm just going to put it as C. And the temperature change is 25 to 80. In the stress of an exam, I would use a calculator even though you can do it in your head, just to make sure 80 take away 25 is 55. I would simplify this 3 times 55 to get 165 times C. So 100,000 equals 165 times C. We're trying to get the C on its own. So we do the opposite of times 165. So 100,000 divided by 165 equals our C. Again, put it into the calculator just as you see it on the screen. 100,000 divided by 165. Press the SD to get out the fraction. Press the SD again to get rid of the recurring. So we've got 606.0606. So 606.0606. And if you're unsure about the units, you can work it out using the equation. So energy equals mass times specific heat capacity times temperature change. So we know energy is in joules, mass is in kilograms. We don't know what specific heat capacity is, but we know temperature change is in degrees C. The opposite of times kilogram is divide by kilogram. The opposite of times degrees C is divide degrees C. So it's joules divided by kilograms degrees C, which equals specific heat capacity. So we write that unit as joules per kilogram degrees C. So that's our unit, which we can then put as our answer. Joules per kilogram degrees C. And this trick works with pretty much any equation apart from pressure, because that's measured in pascals.